While we know a great deal about the cell and its functionality, we've only scratched the surface of its inner workings. Scientists are continually discovering new information and data concerning the cell and its DNA. As our knowledge increases, it gives us a deeper understanding of how complex a single cell really is. And as we ponder this miniature marvel, we begin to wonder, could this simple cell have evolved from the elements of the earth over time? Is it possible for this to have happened by natural processes?
Well, we're not the first ones to ask this question, and it's a difficult question to answer. In the field of information science, there are rules for probability which help us define and understand the possibilities of an occurrence. So to answer that question, we must first define the terms of probability. There are a number of important terms related to probability. Terms you may have heard, but you may have misconceptions as to their meaning. They are possible, feasible, probable, infeasible, and impossible. Without fully understanding the meaning of these terms, you won't be able to make an intelligent, informed decision concerning the origins of life. And when these terms are not understood, people can easily be misled into believing something is scientific fact, when in reality, it's just speculation. Well, let's get started. The term possible, in the context of science, means a non-zero probability. In simple terms, possible means the event could happen. But this term should only be used when known science demonstrates that to be true. It would not be scientifically accurate to state it's possible for a die to be rolled and end up on edge unless it's been demonstrated that the on-edge result is, in fact, possible. Scientists commonly make the mistake of using the phrase, it's possible, when in reality, they should be saying it may be speculated. Now, at first glance, this may seem like semantics. However, to an information scientist, these differences are what define science. If a person uses the term possible, then he or she must verify that the assertion they're making is indeed possible using known science. The term feasible is similar to possible because it too is a probability that also needs to be verified using scientific principles. If an outcome is feasible, it means it's capable of being done or carried out. On the contrary, when we talk about infeasible, we're saying it is impractical or unworkable, not capable of being carried out or put into practice. Now, an outcome is considered probable when its possibility of occurrence is at least 50%. For example, in rolling a pair of dice, it's probable that the sum will be greater than 6. Why? Well, there are a total of 36 possible outcomes when rolling a pair of dice, and of those 36 combinations, 21 of them lead to a sum greater than 6, giving us a 0.583 probability, or more than 50%, that the sum of both dice will be greater than 6 on any given roll. If the public is educated and understands the scientific meaning of probable and what it means to be possible, it will cause scientists to be more diligent and accurate when making their declarations. Impossible simply means there is a zero chance of occurrence. However, when a probability becomes too small, it can be deemed operationally impossible or infeasible, meaning that we understand the possibility of it happening is greater than 0, but for all practical purposes, it's recorded as impossible. Now, when something is deemed operationally impossible, it's still technically possible. So some scientists try to justify arguing endless hypothetical scenarios simply on the grounds that they're theoretically possible, and then try to convince the public that something must have happened because it could have happened. An excellent example of this comes from the noted biologist George Wald.
He once stated, when asked about the origin of life, however improbable we regard this event or any of the steps it involves, given enough time, it will almost certainly happen at least once. Time is the hero of the plot. Given so much time, the impossible becomes possible. The possible becomes probable. The probable becomes virtually certain. One only has to wait. Time itself performs miracles.
Let's hope that future generations will develop a keen awareness of this kind of wordplay and use critical thinking to distinguish between probable explanations and pure unscientific speculation.
The fact that you're watching this video shows that your instructor and you value critical thinking and the very definition of science. You want to know. You want to understand the world around you. And it's a beautiful thing to look out there and ask those questions and never allow yourself to be put in a box where you can only think of one possible explanation for how things came to be or how things work. Look outside the box. Develop that critical thinking to look at all the options and say, where does the evidence lead? And what is the best explanation for why this came to be?
So, what is the probability of a simple cell evolving by undirected natural processes?
The probability of a single protein being formed by undirected natural processes is only 1 in 10 to the 164th power. That's 10 with 164 zeros following it. That's pretty big. The probability of life, a simple cell evolving by undirected natural processes, is 1 in 10 to the 340 millionth power. That is unimaginable. Here's an illustration to help demonstrate just what this means.
Here we have one tiny grain of sand. It's been estimated that there are 1 million grains of sand in a half a cup. It would take 1 million half cups of sand to fill a swimming pool that's 6 feet deep and 30 feet in diameter. Now, if we took 1 billion of these pools of sand, we could fill Lake Tahoe in Nevada, which is about 22 miles long and 12 miles wide.
Think you could find that original grain of sand we started with? We're not done yet.
It would take about 1 billion Lake Tahoes to fill the volume of the Earth with sand. The probability of grabbing that original grain of sand out of the Earth filled with sand is 1 in 10 to the 30th power. It would take 100 million Earths to fill one sun with sand, and 1 trillion suns to fill our solar system, 10 trillion solar systems to fill 1 cubic light year, 100 trillion cubic light years to fill the volume of the Milky Way galaxy, and finally 10 billion Milky Way galaxies to fill the observable universe. Whew. That is a lot of sand.
The probability of now randomly picking our original grain of sand from the entire observable universe is 1 in 10 to the 96th power. Still a far cry from our protein being formed at 1 in 10 to the 164th power, and even less chance of life evolving from undirected natural processes at the probability of 1 in 10 to the 340 millionth power. Starting to get the idea?
Scientists generally consider anything with a probability of less than 1 part in 10 to the 70th power operationally impossible. And by the way, that calculation doesn't take into consideration the information that's stored in the cell, which directs the cell in all aspects of operation.
That estimate is solely the chance of chemicals combining to form something living.
So, the chance of life evolving and retaining the information needed to replicate itself is astronomically smaller than anything we know. And that's only one organism. Think about what it would mean for millions of complex organisms to have evolved from an undirected natural process.
According to information science, the probability is so small that it's deemed operationally impossible. So, knowing all of this, should the popular scenarios of chemical and biological evolution be taught globally as the only explanation of the origin of life and species? It's my belief that we're not opening our minds to the possibility of other explanations. Now, one of the most basic concepts you should have learned is that if observations and data contradict the theory you're testing, then the theory should be modified or abandoned. Unfortunately, this doesn't seem to be happening to the present, most popular model of origins. Instead, many scientists are trying to take information and make it fit the evolutionary models. But is that good science?
Critical thinking is required to realize the information science aspects of this and to make sure that whatever scenarios you're coming up with do not violate the principles of information science. Too often, scientists, they believe that information can be generated by physical processes, and that simply is not true. Functional information cannot be generated from purely physical properties.
Sigmund Freud once said, "From error to error, one discovers the entire truth." As we examine history, we are constantly reminded of our ever-evolving thoughts in science. We look at the ideas of the Earth being flat, or being the center of the universe, or the cell being the simplest component of life. And while these theories seemed promising at the time, we have discovered they are completely incorrect. As we learn more about this amazing world in which we live, we start to understand the complexity of its workings. And in the case of the cell, the more we research, the more complex it seems to be.
As we gather information, it is up to us as scientists, students, and colleagues to bring science to a level of integrity and critical examination that it deserves. If we approach science with an unsupported prearranged bias, then what we're trying to accomplish is not really science at all. The beauty of science is that we're able to move away from accepted dogma to examine the evidences. It's not up to us to disprove a given theory. It's up to the theory to prove itself against the laws of science. If a theory fails to do this, then it should be rejected, and we should search for more knowledge in order to, as Sigmund Freud said, discover the entire truth. The possibility of life evolving using the known laws of chemistry and physics is operationally impossible. When we consider the laws of information, that possibility now becomes impossible. Meaningful prescriptive information cannot arise from nothing, no matter how much time you allow. And until we acknowledge this, we will never discover the origin of life. Thank you for joining me on this amazing journey through science and the programming of life. I would challenge you to examine the evidences and join the growing community of critical thinkers. Until next time.